Thank you. Hello. I am Julien de Visscher, founder of two companies in Brussels, so I come from Belgium, and two companies with a common objective is to build differently. So my first company is MCB Atelier, MCB Workshop. Companies specialize in wood transformation. To put it simply, we process wood for other people, for other companies. Our clients are carpenters, designers, door suppliers, theaters, event company for whom we manufacture single projects or serial productions. Our ambition is to specialize in transformation of reclaimed wood. We have been investing for 5 years in the latest generation of numerically controlled machines, CNC. And this digitalization and scanning allow us to work with any type of wood, origin, quality, dimension, etc. When it comes to reclaim wood, nothing is standardized, and technology allows us to quickly find profitable production solutions adapted to these varied supplies. This is our workshop and machine we had. So we have a lot of CNC, like you can see. The current situation of the new wood supply, I don't know in England, but in Belgium 1 or 2 years ago, it was insane to work with wood because of the high cost and the shortage. So this situation is redistributing the cards of the wood market. And working with reclaimed wood is no longer only an eco-friendly obvious choice, but also an economical one. If before we had a fragile balance between the decrease of the production costs, thanks to the technology, and the increases of the wood cost related to the labor necessary to the recuperation and the preparation of the reclaimed wood, it now appears that in our business, 8 times out of 10, reclaimed wood is more profitable than new wood for an equivalent quality. The other advantage, and this is my favorite advantage, of this strategy of digitizing the production and use of reclaimed wood, it's that it allows us to develop a local and profitable production ecosystem as well as a local supply, wood supply, which brings jobs and more partnerships. I will show you 2 examples that we had realized. The first one is a staircase made with 600 tables from the former cafeteria of the European Commission, which is located 8 kilometers from my workshop. We proceed more than 1,500 pieces assembled wine by wine for this project. It was very fun. So you can see the table we used, the beginning of the construction, and this is what it looks like now. And I like the idea to make stairs with a table. The second one is a bench. It's a bench sculpted in 3D and made with old laminated beams that we reclaim from a construction site 500 meters from our workshop. So you can see the laminated beams. I think it was 40 pieces. It's always a big puzzle. And when it's finished, it looks like that. So I said I have 2 companies, so this is what I do with my first one. And with the second one, in this will to build differently to save our resources, we also develop our own product, the mods. So the mods is very simple. It's a small wooden frame that we use to create a structure. That structure can be a stand, an office partition, reception desk, a structure for a theater set, a podium, store layout. And on this structure, we put finishes and accessories according to the customer specification. This allows us to have a multi-sectorial product that can be assembled, disassembled, reused, and evolve over the time. You have some example of what we can do with the mods. Here we are. This is a box office. So if you want more information about mods or the digitalizing of the production, you can scan and call me. So thank you for your attention.
Okay, so as part of Smarts, we're going to explain what we do in terms of our production and what we do. We're on the stand just over in the corner, but they're going to talk about innovations, so Smarts innovations. In terms of those innovations, it's about making things greener. So that's our embodied carbon. We're going to have a look at the carbon. We talked about recycling, the recycling of aluminium, and also what's important to everybody, particularly with the price of fuel at the moment, is how we can help to make buildings warmer. So how we can improve the thermal efficiencies. So greener, cleaner, and warmer. If we start off with the greener, but first of all, let's just introduce Smarts. Smarts Architectural Aluminium. We're UK's leading supplier of aluminium extrusions. We're known for our quality, design, innovation, and technical expertise. And you'll see us just on the stand over in D10, which is S1, so it's the first entrance to the show. So if anybody wants to go and have a look at the products, but effectively we do windows and doors for the building envelope. We also do things for inside buildings, so internal partitions. And for the outside, we've got things like pergolas and decking systems as well. So extrusions used on buildings. Okay, this is where we're based on stand D10. But in terms of where we're based in the UK, we're just outside of Bristol. Our facilities are quite significant, and that's where we extrude the aluminium. So that's where we make the profiles. We moved to that site in 2005. Okay, and in 2010 is when we've dropped in the first extrusion press. The first extrusion press allowed us to extrude in the UK. Before that, we were extruding in Belgium, so we were importing our extrusions. Since then, we've done a further 3 extensions and 3 further developments on there. And this year, we're dropping in 3 further extensions. So we're dropping in a door plant, we're dropping in an extension to the back of the extrusion line, and we're dropping in a 4th extrusion press. Okay, so you can see significant growth over the last 30 years. The production facilities is around 60,000 square meters. To put that in perspective, it's about half the size of Excel. Okay, so if you take one side of Excel, that's the total footprint of Smarts, and that's been growing since 2005. Okay, that's our physical footprint, as opposed to obviously our carbon footprint. So our physical footprint has been growing significantly, and with that comes challenges. Those challenges are obviously the environmental challenges on there. As part of our group, sustainability is core to that growth. So sustainability rating, we've been awarded gold sustainability rating, which means that we're very good in terms of our sustainability credentials. Partly that's down to the aluminium as well. Aluminium's life cycle is considered to be one of the greenest metals on Earth. Okay, so it's a very good green material. In terms of the life cycle of aluminium, we're not directly involved in the upstream process of aluminium. So here we've got bauxite mining, aluminium refining, smelting and casting. So that's making the actual aluminium extrusion, making the aluminium itself. The part which we do is the extrusion, so that's shaping the profile. Okay, so we're an extrusion company and we supply to manufacturers across the UK. Over 500 manufacturers make windows and doors and construction products out of our materials. So aluminium is a relatively new material, actually. It was actually discovered in 1825 by a Danish chemist, Hans Christian Ørsted. At that point, aluminium was more expensive than gold. Okay, so it was a very expensive material to produce. It wasn't until 1886 that a high-volume, low-cost method of producing aluminium was produced, and effectively that made it commercially viable. It went from being more expensive than gold to being around the same price as silver. Okay, and it took 61 years development, so that's one of those innovations to make aluminium sustainable. Okay, there we're not talking about carbon footprint, it's cost, but obviously the reduction in cost shows you what the embodied carbon was. It went from over $545 to $17 per pound. So a 3% of the cost, significant sort of saving over 61 years. Okay, there's still further developments on aluminium as well. Alu plus C minus is a carbon initiative, so it's low carbon aluminium. So we're trying to reduce the amount of embodied carbon content within aluminium. As we probably all know, aluminium is 100% recyclable, and one of the important things about aluminium is it doesn't lose its material qualities when it's recycled. So aluminium can be indefinitely recycled. You can keep making new cans, new buildings, new different products out of that. So it doesn't lose its material qualities. And one of the key drivers in that recycling is that aluminium, when it's recycled, it only takes 5% of the original energy as what the raw material takes. So there's a commercial incentive to recycle aluminium as well. Recycling of PVC and other materials is relatively new, but aluminium, when I was a young boy growing up, there was always a scrap man collecting aluminium. I remember Blue Peter, and there was a Blue Peter appeal, collecting milk bottle tops. Okay, so aluminium has always been a material which has been very good for recycling. The stats behind it are quite impressive, in fact. 75% of aluminium which has ever been produced is still in use today. Okay, so very little aluminium actually goes to landfill on there. So it's a very sustainable material. This is what Smart's purchased. So this is the raw material. 40% of aluminium, okay, has already been recycled. Okay, so you'll see that we've got a high recycled content on there. So in here, there might be a milk bottle top from a Blue Peter appeal from the 1980s. Okay, so the material is heavily recycled. As I said, Smart's process is the extrusion, which in the supply chain is that little area there. And I'll just show you our extrusion presses. What we do is we take the billet and we warm it up to about 500 degrees C. Okay, 500 degrees C, the melting point of aluminium is 600. So it's less than the melting point. It doesn't look any different. It just got a warm temperature on there. But then we'll push it through a die. The extrusion die is shown here. Okay, and that shapes the profile. And this is a typical extrusion, which would just take out the other end. As what Smart supply, it's lengths of profile, which can then be used to make building products on there, whether that's windows, doors, or different products on there. Our facilities, we've got 4 extrusion presses in the UK, and the output of those 4 presses is 40,000 tonnes. Okay, so a significant amount of aluminium is processed through that facility on there. We're part of a larger group, and across group we've got 16 presses based around the UK. Based around Europe, servicing each individual market on there. So we've got Belgium, we've got France, we've got Poland, Portugal, all have got their own extrusion presses. We also drop into thermal brakes, and we also distribute out to those fabricator base. Okay, downstream to Smarts is the extrusion process. So Julien explained about CNCing of timber. Okay, our fabricators, our manufacturers will take that profile and they'll do the preps in there. So there might be a hole, for example, which is a hole for doing a keyhole in there. It might be a hole for a lock on there. So they'll prep and manufacture the material so it becomes a window or a door. You'll see the shape just being produced there is a keyhole for a window, okay, or for a door. Okay. If you're wanting to see some of those preps and those in real life, like I say, we're just on stand D1, okay, which is just on the far end of the hall on there. So you can have a look at the different products on there. Okay. Smarts, sustainability is core to one of those key factors on there. We've also got 14001 and BES 6001 environmental standards. We've been monitoring our environmental greenhouse gases since 2012. Okay, so our greenhouse gas data has been monitored, and it allows us to innovate to reduce our greenhouse gas emissions. Okay, so we've been collecting that data since 2012. Simple examples of that is every single piece of kit at Smarts has got a little device on it, and it shows you how much energy is being used on those individual devices. So it allows us to see if anything's misfunctioning. It also allows us to see if we can improve any of the equipment on there, and that reports to a central database. And that allows us to also predict what our greenhouse gas emissions are. And you'll see they've dropped significantly. So over 5 years, we've halved our greenhouse gas emissions. So you saw our footprint increase, but over 5 years our greenhouse gas emissions have halved. That's partly through economies of scale, so because we've expanded, we're doing more. Okay, but if we look in real terms, we're about a third less greenhouse gases than what we were on 2016. Okay, so significant sort of savings on there in terms of benefits of which we're doing. The embodied carbon of a piece of aluminium is around 5 kilos of CO2, 5 kilos of CO2 per kilo of aluminium. Okay, and that can be broken down to billet production, so the actual raw aluminium production, transportation to smarts activities, and then distribution out to our manufacturing bases. Okay, so it gives you an idea of the extrusions on there. Okay, our contribution is about 5% of that, so the majority is the actual aluminium production, but as we've seen, there's already enhancements in terms of producing coming down in terms of the aluminium production. If we look at a typical window, because 5 kilos doesn't really mean that much, if we look at a typical window, this window is about just over a metre wide by a metre high. Okay, the amount of aluminium on that window is going to be about 6 kilos. So if we said it's 5 kilos of CO2, it works out that we've got 30 kilos of CO2 on a typical window. If we compare that to the glass, this is based on Saint-Gobain's data. Saint-Gobain have got 34 kilos per square metre of product on there, so their contribution is about 50 kilos of CO2. Okay, so the total on a new window, is around 80 kilos of CO2. Okay, if you're wanting to work out what that is in sort of real terms, it's around a car journey of around 220 miles. Okay, so the distance to smarts is about the embodied carbon in one window. Okay, so a car journey. Okay, so we can see we're very low in terms of our carbon footprint. What's probably of interest to you guys is how the windows can make things warmer on there. Okay, so that's the U value of the window, which is the energy efficiency of the window, and what energy savings we can entertain on there. Okay, windows, they're not relatively new. We've been using windows since the 1700s. Okay, so common use of windows was in the Georgian periods, and you'll see a lot of the windows in the Georgian periods would have looked like this, and it would have been typical single glazed windows. And in fact, we've still got a lot of building stock which has single glazed windows in there. A single glazed window is typically a U value of around 6. Okay, it wasn't until 1995 that we had a building regulation for conservation of fuel and power. So any building stock before 1995, potentially if it's single glazed, it would be as high as 6, but it was unregulated, was the thermal performance of windows before 1995. The limiting U value for new build has been decreasing over that period as well. So in 95 it was 3.3, casting our minds back to then, and now the limiting value is about half that, so it's 1.6 is the limiting value. We've also got SAP calculations which drive that down even further, but that shows you the improvements of U value over time. Okay. In terms of a U value of a window, okay, we don't actually have to physically make a window or a door in order to work out a U value of a window. We actually use some computer software, so we use thermal modelling software, which allows us to accurately predict the temperature flows across a window. So this piece of software is called Visscher, and it will allow us to take a cross-section of a window, and it will produce the hot and cold spots within a window, and it allows us to optimise the best energy efficiency of a window. So if we take a typical section of a single glazed window, you'll see the colour contours across there. It's all showing blue, so it's quite a cold window on there. The first generation double glazing would have been non-thermally broken frames, and probably with an air fill on there instead of any gases within the cavities on there. So you're starting to see temperature differences across the glass, but the frames are still relatively cold on there. Current generation of windows have got thermal breaks within the system, and we've got gas fills within the glass units on there. So that's a typical current double glazed system on there. It's got polyamide as a thermal break within the system, and that helps stop that heat transfer through the system. So it stops that cold air going in, and it helps reduce that heat transfer across the window. The glass has got thermally broken spacer bars. So if you look at an old-fashioned window, the spacer bars would have been silver. So when you look inside the window, they're silver. You'll see all modern windows, they tend to be black, or there tend to be a black spacer bar in there, and that's because it's made out of plastics, because it's the thermally enhanced spacer bars. But glass technology has improved significantly as well. So we've got low emissivity coatings, which is effectively, it's like a very thin silver layer on the inside sheet of glass, which reflects the glass on there. If anybody remembers Pilkington's K adverts, Pilkington's K would be a low emissivity coating, which is a hard coat on there. And also we start to fill the glass up with argon. Okay, so that's thermal enhancements to a window. Okay. The centre pane, which is the heat loss through the glass for a typical sort of single glaze unit, as I said, is around 6. For first generation double glazing is around 4.74. For first generation double glazing with fills is around 1.5. Okay, so Pilkington's K glass was 1.5, but they've improved the technology, so they've gone to soft coats, and now we're looking at 1.0 as a centre pane. Okay, so that gives you the heat loss through the glass as a centre pane as watts per metre squared Kelvin. Okay, if we look at triple glazing, okay, so things are moving on to triple glazing. Basically, we can halve our heat losses with triple glazing. So a 1.0 centre pane will drop down to a 0.5 centre pane. Okay, so it shows you what enhancements we can do. And really, we're seeing a lot more call for triple glazing, particularly in the new build market. It's now accounting for 5 to 10% of installations are asking for triple glazing. Okay, they're centre panes, okay, which in watts per metre squared Kelvin, okay, which don't really give you any sort of indication of actually what your heat losses are. That can be converted into annual heat losses, into kilowatt hours per metre squared, based on typical climate data. Okay, so this is based on BFRC UK climate data. Okay, so it's based on the UK, so obviously if it was a colder climate, the savings would be higher. If it was a warmer climate, the savings would be less. Okay, but on a single glazed sheet of glass, typically you're losing around 400 kilowatt hours per square metre. On a first generation double glazing, it'll be 325, around 70 for current generation double glazing, and triple glazing is 36 kilowatt hours per square metre. Okay, that gives you the kilowatt hours, but everybody's interested in terms of the cost. Okay, so if we convert that to costs, this is the annual heat loss out of a window. Okay, so the annual heat loss for single glazing is typically around £40 per square metre. For first generation double glazing will be £33. A current generation double glazing is about £7, and you'll see we can halve that if we go on to triple glazing. But these are annual heat savings or heat losses through a window. So actually, when we look at the heat losses, we're talking about quite low numbers per square metre. Sorry, I've got a bit of a tickle. So that shows you the actual heat savings. Obviously, it affects the comfort of the windows as well. So the temperatures, we can accurately predict the temperatures of the window. So if we look at the internal surface temperatures, we go from being 4 degrees to being 15 degrees. And this has been simulated on a typical scenario of 20 degrees inside, 0 degrees outside. Okay, so it gives you what the expected temperature differences on those windows are. That allows us to accurately predict also what point condensation occurs on there. Single glazing for condensation is quite likely. Okay, and if we base it on typical internal conditions of 20 degrees C, 55% humidity, then condensation is quite likely to occur when the temperature, believe it or not, drops below 8 degrees. So on single glazing, we'll see condensation is very likely in terms of on the surface temperatures on there. First generation double glazing, because the frames weren't insulated, would still be around 7 degrees. Current generation double glazing, the temperature externally gets to around -6 degrees before we'd expect to see in normal conditions condensation forming on the frames on there. Okay, obviously the building fabric would have an influence on that as well, so this isn't idealised scenarios on there, but -6 degrees for double glazing. If we look at triple glazing, whilst it was only £3 saving per year, the condensation benefits are significant. It would need to get to below -25 degrees, around 24 degrees, before condensation is likely to occur on a triple glazed unit on there. So you can see significant benefits. That's around the lowest temperature which the UK has experienced. So you can see improving the building fabric, not only can we consider our heat losses, but also the risk of condensation significantly decreases as well. Okay, so if we look at buildings, okay, obviously we're in future build. Buildings account for around 30% of our greenhouse gas emissions. Okay, so in terms of achieving net zero as a country, we need to have a look at our buildings on there. Okay, but interestingly, around 75%, so if we're aiming for net zero in 2050, around 75% of the buildings in 2050 already exist. Okay, so we can't just do it through building new buildings better. We've also got to have a look at our existing building stock as well. So, and that source was from 2019. So each year that goes on, we're still adding to that 75%. Some estimates are that potentially it's 80%. So actually the new buildings in 2050 will only be 20% in the future. So as I said, we need to really focus on renovating our existing buildings to upgrade those performances as well. 1995 was the cut-off for building regulations. Again, there's a lot of buildings before 1995. I'll just finish off with a few case studies which we've done, and it'll show you some renovation projects which we've encompassed. So this is Sully Hospital. It's in Cardiff, okay, just on the outskirts of Cardiff. And it was a hospital which was used for treating tuberculosis before there was any remedies for tuberculosis. So the only remedy would be go and sit yourself by the coast and try and get better. Okay, so this hospital was particularly built for that. It went into disrepair and it got converted into apartments. So it's one of these recycling of buildings, so it got converted into apartments on there. But the original windows were steel crittle windows. So you imagine them being on the coast, being steel. They were rusted. They did need replacing before anybody could live in there. Whilst I say it's a refurbishment, because there was a change of use, it was going from a commercial building to a domestic building. In terms of building regulations, it would actually be classified as a new build. Okay, so it had strict thermal requirements on there. The original real windows were installed in 1936, and they were steel windows. But what we've done is we've copied the exact contours and the same look of the windows, but dropped a thermal break into the system, and that's our heritage system. And these are aluminium windows, but with polyamide thermal breaks on there, significantly improving the heat losses across the window, and importantly, producing a building which is compliant, but recycling existing building stock on there. Okay, but that would be classified as a new build. We've also done refurbishments on commercial buildings. So this is a Mount Pleasant sorting office in Clerkenwell, so just up the road from ourselves, and it's had a refurbishment. The original windows were installed in 1937, and they looked beautiful. They were bronze windows, and the architect created a really nice looking window in there. But unfortunately, in the 1980s, they had first generation PVC windows, okay, and the look of the building was diminished. Suddenly you've got these big chunky sight lines on there, you haven't got that contoured look of the profiles on there, and you haven't got the balanced look of the profiles on there, so it changed the look of the building on there. The windows, they weren't specified correctly as well, so some of those windows are 3 meters in height, and all the joints had opened up because the profiles weren't strong enough in order to accommodate the system on there. The architect which was involved in the refurbishment of Mount Pleasant saw the heritage system and wanted to include it on their project. And you'll see the finished article looks more like the original bronze windows with the same contours, same look, that Art Deco look, those very slim sight lines on there. As I said, one of the challenges is it doesn't show it justice, but some of those windows, they're the height of double-decker buses, so they're 3 meters in height on there, and the architect was pushing us for slim sight lines on there. So what we did is we developed a finned coupling profile, and this finned coupling profile is specifically tailored to that project and that building on there, and it suits that wind load, and that allows us to get the strength in there, but that fin goes onto the inside, so it doesn't add to the sight lines of the building. It's only when you're looking through the windows that you'll see this is projecting to the inside of the building. So it allows us to get that strength of the profile, which was up from the original bronze windows, and that slim Art Deco styling. Okay, so that was Mount Pleasant, which is a refurbishment of a commercial project. Refurbishment of a domestic project. We've got the Grade 2 listed Hallfield estate, which is just by Paddington Station. Okay, and it's listed building, so because of that, it was very difficult to get the windows replaced. So this has until very recently had single glazing in there, and all these people have had single glaze, losing a lot of heat out of their windows. There was a complication, so not only was it listed, but you'll see those windows, they're on walkways, and the top window opens outwards, but the bottom windows open inwards. Okay, so that's another complication on there. Traditionally, to do that in aluminium, you'd be putting reversing profiles, which add to your sight line, so it makes it a very chunky window. But for that particular project, again, we did our own development on there. We developed some profiles which allowed us to do that in slim sight lines. So we had an open in window and an open out window with all slim sight lines, and allowed us to get those slim look on there. Okay. The annual savings of the CO2 on that window is around 730 tonnes. Okay, so on that particular project on there, if we're looking at car journey, so we said a new window is about 200 miles. The savings on that one project was 2 million miles, which is 82 times around the world. So significant carbon savings. We looked at the embodied carbon at the beginning, but the carbon savings of that is equivalent to taking 272 cars off the road. So significant savings across there. So you can see we can reduce our temperatures across there. We can reduce the mould across the windows, and we can increase the performance of the windows. So just to summarise, there's a few numbers on there. Just to summarise in terms of smarts, we're a £150 million business. Okay, we do 40,000 tonnes of aluminium a year. Okay, if that was just one profile, that's the circumference of the world in a year. Okay, so significant volume, and that's just supplied into the UK market. There's 600 employees, and we've been in operation for 45 years. Okay, so that just summarises what we're involved in. I think the next talk is going to be about condensation as well, so it just leads on to that as well. But if anybody wants to see us or have a coffee, like I say, we're over on the stand over there. Okay, but hopefully that's given you an insight in terms of what smarts do and what we are. An extrusion die is just there if anybody wants to see how we extrude the profile. Has anybody got any questions on what we've just covered at all? Okay, thank you very much. Thank you for your time on there. Okay, I'll pass you over to Adam, and he's going to talk about similar technology to what we're doing in terms of monitoring our energy use. Okay, but I think he's talking about the temperature and humidities. Okay, cheers, Adam.
Good afternoon. My name's Adam Taylor-Drake from Eco Homelink, and I'm going to talk to you about one of the biggest challenges facing the housing sector currently, which is damp and mould. So what is the problem with damp and mould? Millions of properties are at risk of developing condensation, damp and mould issues. The task of adequately addressing risk factors is complex and requires a multifaceted approach. And this is made even harder by the fact that there's a lack of real-time monitoring and analysis, leading to high levels of non-compliance. Cheers. Thanks. So just a little bit of an overview of the regulatory landscape and what's been happening over the last sort of 6-7 years in terms of damp and mould, compliance and legislation. So we've seen a huge amount of interest and focus in this area, and rightly so, because there's been some very high profile, very tragic cases in the media recently. But it's been a problem that's nothing new. I heard somebody talking a while ago at a conference on housing, saying that this is a Victorian problem that existed long before we've had any kind of modern technology to address it. So one of the things that we're doing is we're pioneering real-time monitoring of environmental conditions, so we can help landlords pinpoint the issues and pinpoint areas of risk. And obviously the government has taken notice in this area as well. So the Housing Ombudsman produced the Spotlight on Damp and Mould report in 2021. So 4 of the main recommendations to senior management was to move from a reactive to a proactive approach. So what does that actually mean? That's rather than responding to damp and mould complaints and then carrying out some kind of repair, proactive means detecting risk and then taking action before the issue develops. The second recommendation was to move from inferring blame to taking responsibility, and this is something that is particularly important when it comes to getting residents on side. The third recommendation is to move from a position of handling disrepair claims going through to resolution. So basically taking the complaint and actually resolving it and getting to the point where the resident's happy. And the final recommendation is to move from a culture of handling complaints to one of learning from mistakes, learning from best practice, and actually improving the way that mold and damp is handled as a landlord. So some recent developments in regulation in this area. So there was the follow-up report to the Ombudsman Spotlight on Damp and Mould in February 2023, which removes resident action as a viable approach to this problem. It's now the landlord's responsibility to take action. Recommends dedicated app to report issues. Also recommends the use of a dedicated condensation damp and mould dashboard, among other things. There was the letter from the Secretary of State, Michael Gove, on November 22nd, 2022. The focus was on taking responsibility for condensation damp and mould, and the onus on the landlords to report on issues of CDM that had been remediated and what was done, and the number of times action had been taken to address CDM issues. Then we had letters from the Regulator of Social Housing, November 2022 to February 2023. These detailed that RSLs needed to produce basically detail of how they're assessing the issues. What steps are they taking to understand the root causes? And probably the most important bit was to have a plan of action, how they were going to go forward and address issues going forward. So the Housing Ombudsman and the Regulator of Social Housing produced some initial publication into their initial findings recently. And one of the things that they found was that most RSLs were taking this more seriously. However, those that were doing badly were still reliant on a reactive approach, and they weren't collecting data or doing any form of analysis, and they had little evidence. So how can IoT help? Eco HomeLink have developed a platform that's specifically tailored to fighting this damp and mold problem. Some of the benefits to residents are improvements to their health, which is an obvious kind of benefit to reducing the risky conditions in their home. Better communication with residents, landlord to resident, and also peace of mind for the residents, which is a really important factor when it comes to things like mental health, well-being. For the landlords, it's the start of a proactive approach. We're starting to hear phrases like worst first, where landlords can prioritise properties that are most at risk. It allows for the first time, it allows landlords to actually look at the interventions they're taking and measure their effectiveness. And one of the recommendations from the Housing Ombudsman is that best practice for this problem is to have a damp and mould dashboard. So that's exactly what we've been building over the last 2 years. So the dashboard is the focus of your damp and mould tackling activities. It allows you to identify and solve root causes. It allows you to carry out assessment on your interventions. It provides compliance assurance, so from early prediction and detection through to resolution, you can measure the effectiveness of what you're doing. It gives you a high-level stock performance of all your houses. And of course, you can send notifications to the relevant people, text and email notifications. So something that we've been working on for a number of years, and this is at the core of our system, and it's our data analysis, which is powered by machine learning. So the root cause analysis of mold and damp, we've divided it into 6 factors, which are easy to understand and obviously easy to pinpoint in terms of where they're originating in the property. So the top part of the graph is your structural factors. So these are things that in a typical home, the resident will have very little impact upon. It's the fabric of the building, things they can't change, such as the baseline humidity. Is there a leak or external damp source? It was interesting reading through the coroner's report for Arab Ishtiaq's death. It was actually noted that the ventilation in that property came from a corridor that was completely enclosed. So the air that was coming into the property was coming from an enclosed space that wasn't receiving fresh air. Another factor is heat dissipation. So is the property able to retain the heat that's being put into it? How effective is the insulation? And the third structural factor is the baseline ventilation. So as I mentioned before, how easy is it for the property to change the air in the room? The bottom part of the graph is the environmental factors. So these are the factors that the property is being subjected to. So the Ombudsman recommends not using phrases like behaviour or lifestyle. So these factors are things that the resident does have some ability to change, but it's something that has to be done as part of a learning process with the landlord. So potential ventilation, is there mechanical extraction at the property? Is it being used? Is it being powered down through cost of living and cost concerns? The heating consistency, so is the property being underheated regularly, or are there certain rooms that are being completely unheated? And the final one is peak humidity. So this is the big one that gets a lot of attention in the media. Things like humidity sources, showers being used without ventilation, cooking without extractor fans being used. So the purpose of this piece of analysis is it allows a landlord to see at a glance what are the most significant risk factors. If it's the top of the graph, it's something that the landlord should really consider investigating as something that's their responsibility. And if it's on the bottom of the graph, it's pointing towards it being something that might be the responsibility of the resident, but it's about having that dialogue with the resident and the landlord and working together. So intervention analysis is all about using the real-time data and the analysis that our machine learning provides to be able to effectively pinpoint the causes of mold and damp, but also to measure the effectiveness of anything that you've done to try and remedy that. We hear a lot of landlords talking about this compliance golden thread, which is where they're able to show detailed information about when an issue was detected, what the conditions were like before that detection, or what the conditions were like before that complaint was made, and what the conditions were like afterwards, after a piece of intervention. So if you think about how you do that without real-time monitoring, it's very difficult. We've been working with landlords who are currently installing damp and mold, essentially humidity data loggers. They go and put them in for 2 weeks, and then they go and collect them. And the only bit of information they've got is that 2-week period, so it's not as effective as a continuous monitoring program. To give you a recent example, so here is some data from a real property, and what you can see on the graph there is the temperature between the recommended minimum maximum. So we're looking about 18 degrees to about 23. So this property's sitting within that quite comfortably. However, in terms of humidity, this property had a serious problem of high humidity for a sustained period of time. So you can see here that above the recommended maximum level, this property spent most of its time hovering around the sort of 80% level. So at this level, humidity is going to form condensation, the walls are going to be damp for a longer period of time, and there's a much higher risk of damp and mold forming in this property. By taking intervention, the landlord is able to monitor how effective that intervention has been. So it might just be as simple as messaging to the resident and saying, you need to ventilate when you're using anything that generates humidity, or it might be the installation of a new and improved extraction system. So the idea is that by knowing the point in time that the intervention was taken, the landlord can measure how effective it's been. One of the ways that we help residents become more engaged in this process is we have the resident-facing app, the Resident app. And at the centre of this app is a little character that we call Linky. He's a little fun guy that the residents can kind of get to know, and also they try and make him happy. So one of the things that a lot of residents get in touch with us about is how do we make our house happy? How do we make our house green? So the face and the kind of mood of Linky will change based on the conditions in the house, and it was designed as a kind of way to engage residents more in the process, show them the data that's being collected. But what we found is it's become a central part of the journey that a landlord will go on with their residents to try and tackle mold and damp. So the residents love the app. The residents are, trying to make their house green, trying to get everything in the sort of the Goldilocks zone, as we call it. And the landlord can then surface messages to the resident and say, you're doing a great job, or maybe you need to do a bit more to ventilate your kitchen. And here's a little bit of a testimonial from one of the landlords we've been working with, Grand Union. So we validated the effectiveness of new ventilation systems we are installing to resolve CDM issues. Real-time data insights provided by the HomeLink portal make it simple for us to make informed decisions on the future specification of fans that are proven to be effective in the treatment of humid and damp living conditions. So that was a really good example of how we helped a landlord basically validate the investment they'd chosen to make in that property and decide whether to roll it out across their whole stock. And we're currently scaling this solution across the UK. We've got about 190,000 connected devices, and more are being added every day. So if anyone wants to come and talk to me about this afterwards, I'm on K32, or I'll be here for a few minutes afterwards. But yeah, thanks very much for your time.